Okay, so this is Matter and Measurement, Lesson 4, and today we are going to discuss how we can use conversion factors to convert from one unit to another. Some of you may find this difficult, but we will do lots of practice problems in class. So all I'm going to ask is that you try to follow along, take your notes, and star something that you don't understand, and we'll talk about it when we see each other. You should be on page 11 in your notes. Top of the page says measurements and the metric system. And in chemistry, we measure matter using what's called SI units. And the SI stands for System International. And you're familiar with this, you've just never seen the name before. So basically, we're talking about our metric base units. You have these listed in your reference table on table D. So the first one is M for meter, you know that measures length, G for gram, it measures mass. Some of the other ones that we are going to use are listed here. You do not have to memorize them. It tells you the symbol, and it tells you the name, and it tells you what it measures. Today we're going to work with the metric system, and we're going to be converting between different lengths. You also have a selected prefixes table, table C, which tells you exactly what all of these prefixes mean. Kilo means 10 to the third, deci is 10 to the minus 1, centi 10 to the minus 2, and these are some of the more popular ones. They haven't included all of them. We will probably work the most with kilo, centi, milli. You might see one occasionally for nano and pico, but we really deal with those more in the next level class. In the next chart that you have, this is another way to display the information. You've got prefix, you have a symbol, and then you have the numerical standard form, and then you also have the exponential form. So basically, all you have to remember is to multiply the root word by whatever you see for the exponent. So for example, in the word kilometer, the root word or base unit is meter, and the prefix is kilo. Well, if we look at kilo, kilo is 1,000 or 10 to the third. So that means to multiply the root word by 1,000. Therefore, 1 kilometer is 1,000 meters. Sounds pretty easy, right? Okay, let's continue. Conversion factors is simply a mathematical expression that relates two units that measure the same type of quantity. So, for example, I'm going to use some things that you already know. You know that 1 minute equals 60 seconds. You also know that there are 12 inches in 1 foot, or you should. And you might even know that 1 inch is equal to 2.54 centimeters. I'm hoping that one of your other teachers may have brought that up before. Rest assured, for the regions, the most you will have to convert will be between the milli, kilo, base unit. And that could be in grams, so you might be converting milligrams to kilograms, or kiloliters to liters. This is always a matter of 3 and 6 decimal places. And I'll explain what I mean by that. You must also make sure you move the decimal the correct direction, either right or left, which depends on whether you're converting from small or larger values. So when we talk about the base unit here, okay, this base unit can refer to meter, gram, or liter. I'm just going to put the symbols, capital M, meter, capital G, gram, L, liter. So there's two ways we can look at this. If I have 1 kiloliter and I want to know how many liters that is, so I'm going from kiloliters to liters. So 1 kiloliter to liters. How many decimal places am I moving? Well, look, let's see. I'm going from kilo to hecto to deca. So I've moved 1, 2, 3 places. So all I really have to do is take my 1 kiloliter and move 3 decimal places. So that means I'm adding 3 zeros. So that's 1,000. Or I can go back to my chart on the previous page, and we know that kilo is 1,000, and my root word here is liter. So we take 1,000 and we multiply it by liter, so it's 1,000. Notice I'm going from something very large, kilo, to a base unit. What if I were going from milli? Let's take milligrams, so I have 1 milligram, and I'm going to grams. So now I'm moving to the left 3 places. 1, 2, 3. So 1 gram is equivalent to 0.001 milligrams because I moved 3 places to the left to go from milli to the base unit. Now, sometimes students have a hard time remembering the order of these because we don't use all of them. We don't really use hecto or deca or deci in chemistry. We use kilo, the base unit, centi, and milli. There's 2 ways that can help you remember it. One is kids hate doing math during cold months. Some kids hate doing math anytime. And this will help you remember the order. Each letter of the word stands for something. Kids is kilo, hate is hecto, doing is deca. Math is your base unit. Could think of it as meter, during is deci, cold is centi, and M is milli. Okay, let's try to do a couple practice problems here. A car travels 845 kilometers. How many meters is this? Well, I'm just going to use my little slide scale to do some of these. So I've got kilo, hecta, deca. This is my base unit. And then I've got deci, centi, and milli. All I did was write it down here. You don't have to do it because you're looking at your whole paper. So if I'm going from kilometers to my base unit, which is meters, you should see that you're moving 1, 2, 3 places to the right. So I take 845 and I move 3 places to the right, so I'm going to add 3 zeros. So 845,000 meters. If we're converting liters to milliliters, liters is my base unit, so I'm starting in the middle. Oops, I'm sorry. Yeah, liters to milliliters. So I'm starting it in the middle, and I'm moving 3 places to the right. 1, 2, 3. That gets me to millis. So let's take our decimal move it 3 places to the right, 1, 2, 3, and we should get 29.0 milliliters. Again, we're going from milliliters to liters now. So now I'm starting on the right side of the scale. I'm going to change this so you can see where I'm going. I'm going from milliliters to liters. I'm going from milli to my base unit. So I'm moving 1, 2, 3 places to the left. So I start at the end of 2500. I move 1, 2, 3 places to the left, and I get 2.5 liters. Okay, let's do number 3. We're going from grams to kilograms. Grams is my base unit. Grams is my base unit. So I'm starting in the middle and I'm going to kilograms. So I'm going 1, 2, 3 places to the left. So if I have 3 and my decimal is after the 3 and I'm moving 3 to the left, 1, 2, 3, that means that my answer is going to be 0.003 kilograms. Number 5, I'm going from kilometers to meters. So now I'm starting all the way at the left. I'm going from kilometers to meters. Meters is my base unit, so I'm going 1, 2, 3 to the right. So I'm going to take 1 kilometer and move 3 to the right. That means I've got to add 3 zeros. So 1 kilometer is 1,000 meters. I want you to pause me for a minute and I want you to try to finish the last 6, and then I want you to start the video again and check your work. Okay, hopefully you paused me and you just didn't watch me do all the work, and now you're going to check your work. So 1 kilogram to gram, we're going exactly how we did in 5, except for we're not talking about meters now, we're talking about grams. So it's still going to be 3 to the left. So it's still going to be 1,000. 1 kilogram is 1,000 grams. In 7, we're going from liters to milliliters. So we're going from the base unit, 1, 2, 3, to the right. So 1 liter is 1,000 milliliters. In the next one, in 8, we're doing the same thing. We're just going from meters to millimeters. It's still 3 to the right. They just changed the base unit. Instead of talking about volume, we are talking about length. So 7 meters is 7,000 millimeters. And in 12, we're going from milliliters. So we're going from milliliters, 1, 2, 3, to liters. We're going 3 to the left. So if I have, that's a bad color. If I have 12 and my decimal's here, 1, 2, 3, my answer is going to be 0.012 liters. Now in 10 and 11, I hope you realize that in order to answer this question, you have to have agreement of units. So you either have to choose to change centimeters to meters or meters to centimeters. Well, I'm going to work with my base unit just because it's easier. Meters is in the middle, centimeters is 2 to the right. So if I go 2 to the right, that's going to be 600 meters. So when we compare, centimeters. When we compare 56 centimeters to 600 centimeters, we can see that obviously 56 is less than 600. In the next one, let's change 7 grams to milligrams. Grams is our base unit. Milligrams is 3 to the right. So I'm going to move the decimal 3 to the right. So 7 grams is 7,000 milligrams. And when comparing that to 698, we know that 7,000 is a whole lot larger. Okay. Hopefully, once you checked your answers, they made sense. We're going to do one more thing today. I'm going to talk to you about dimensional analysis. And dimensional analysis is a big word for unit conversions, but I'm going to teach you a specific way to do this. Some of you are going to find this difficult in the beginning, but once you've done a couple of practice problems, it won't seem so bad. So dimensional analysis is just a fancy term to convert from one unit to another using conversion factors. Remember I told you 12 inches is a foot, 2.54 centimeters is an inch, those kind of things. We will use conversion factors to convert from 1 meter to another. And I'm going to go through this in sequential steps, but it's really one long step. So the first thing that you want to do is write the term to be converted. You have to include the number and the unit, and this is important because the reason why dimensional analysis works, it's because it's a process of canceling units. So we're going to write down 6 centimeters because that's the unit that we're converting. It says convert 6 centimeters to kilometers. Write the conversion formula. So what do we know about centimeters to kilometers? Well, let's break it in small steps. If we use our chart, we know that to go from kilometers to meters is 3 places. So 1 kilometer is equal to 1,000 meters. That could be one conversion factor we would use. Then, if we look at meters to centimeters, we know that in looking at our chart that centimeters is 2 places to the right of meters. So 1 meter is equal to 100 centimeters. Now we're going to make a fraction of the conversion factor such that the denominator units are the same as the units from step 1, and the numerator contains the units you want to convert to. So I'm going to bring down 6 centimeters down here, and we're going to put that over 1. Now, in order to cancel centimeters, I need centimeters to be in the bottom. So we know that 1 meter is equivalent to 100 centimeters. If I write 1 meter on top and 100 centimeters in the bottom, then my centimeters cancel. But now I'm left with meters in the numerator. That's not what I want to get to. I want to get to kilometers, so I'm going to keep going. However, this time I need to write meters in the bottom, so meters cancel. So 1,000 meters on the bottom is equal to 1 kilometer. Now my meters cancel. And look at, lo and behold, I am left with units of kilometers. Well, you might be thinking, how do I solve this problem? Well, this is simply a fancy multiplication division problem. I am now going to take everything that's in the numerator, 6 times 1 times 1, and divide it by everything in the denominator. So in my calculator, I'll put 6 divided by 100 and then divided by 1,000. I get 6 times 10 to the negative 5 in scientific notation. If I want to write this out, we have multiplied the term. It says in number 4, multiply the term in step 1 by the fraction in step 3. Well, we've done everything all at once, and we've canceled out like units. We canceled out centimeters and centimeters, meters and meters, and we're left with kilometers. So in number 6, your last box, you can definitely put the answer 6 times 10 to the negative 5 kilometers. Or you can write it out in standard form. I want you to do the last problem. Let's do it together. I don't have it here. It says, now you try one. How many minutes are there in the month of October? So October has 31 days. So that's what we're starting with. And you have to convert this to minutes. So you need to be thinking about some conversion factors. So what do we know about a day? Hopefully you can tell me that 1 day equals 24 hours. And hopefully that you can tell me 1 hour equals 60 minutes. These are conversion factors. And we are going to use them to convert 31 days to minutes. So if I'm starting with 31 days and I want days to cancel, then you should realize that the day has to be on the bottom. 1 day equals 24 hours. My days cancel. I'm only at hours though. This problem is asking for minutes. So in my last one, I'm going to put an hour on the bottom and 60 minutes on top. And then my hours cancel. I'm left with units of minutes, which is what I want. and this becomes a math problem. 31 times 24 times 60. And I only have a 1 in my denominator, so I don't have to divide by anything. I multiply these three numbers together and I get 44,640 minutes. And that's tonight's lesson. Don't forget to study for your quiz. Everything in the beginning of the unit. That includes elements, compounds, what are they, particle diagrams, heterogeneous and homogeneous matter, and various techniques of separation. Have a good night.